Hello, hello. I'm Adam, and I'll be talking about my project, learning world knowledge from cooking recipes that I worked on with Tamara Berg, Alex Berg, and Miko Marquez. So here's some background and motivation first. So one of the major problems in computer vision is image classification. That is, given an image and a set of labels, can we assign the correct label to that image? So can we say that this is a grill, that this is a mushroom, this is a Dalmatian? There are several current methods that do this, and they do pretty well. And the main baseline for this is using the ImageNet database across a thousand different categories on a million different images. But what if we want to learn more than those 1,000 categories? What if we want to know something different? So like, what is this part of a car or something like that? Like, what is this image? Is this an apple? Is this a sliced apple? And ultimately, this is also a problem for language, right? Because how would you describe this image? With language, it's an apple, right? It's a red apple, it's a sliced apple. So how do we learn more about these states? Well, we could look online on different word databases. So WordNet is a database that has all sorts of different things. So if you search for apple, it'll give you some information about it, and then you can search different hypernym trees, which is like an apple is a kind of fruit, which is a kind of edible object, et cetera, et cetera. But when you search for something like sliced apple or apple slice, you don't really get anything back. There isn't really that information there. So where can we learn about these different states of objects and ingredients? Well, cooking recipes have this information, right? Because cooking recipes are essentially ingredients which have ingredients which go through different actions to go through different states. So in this case, you might have an apple, which you slice to get sliced apples, which you put into a pie, which you bake to get an apple pie. So why might this information be useful? Well, in the domain of cooking, you might want to auto-illustrate recipes. So given some set of instructions here, we want to assign some corresponding image that tells us basically what to do, right? Like, so let's say I'm a terrible chef or something. Or you could go the other way around. So given some cooking video, we could annotate it ourselves with some generated captions. So here it's like lay the pie crust in the pan, fill it with apple slices, and then later on the person flattens and cuts the pie top and puts it on top. So what did I do specifically? Well, first I had to collect some data. So I went to recipe.com and I did a bunch of queries on different ingredients like apple, tomato, pear. And then I took a couple hundred recipes from each of those. That gives me about 7,000 recipes across about 20 different ingredients. And from those recipes, I want to take those and make some knowledge representation of those. So we can use a graph for that, where the nodes are the different states of ingredients, and the edges are the actions on those states. So in this case, we have apple, which you slice to get an apple slice, or you mash to get applesauce, and something like that. And ideally, we'd like to have one of these for every single type of ingredient. So how do we exactly extract the objects and actions? Well, we can use the underlying structure from the sentences here. We use the Stanford NLP pipeline, which is the natural language pipeline, to do all sorts of things like part-of-speech tagging, constituency parsing, and dependency parsing. So part-of-speech tagging is things like finding out that slice is a verb, that apple is a noun. Constituency parsing is finding things like the apple is a noun phrase, or slice the apple is a verb phrase. And verb phrases are important in this case because we want to find verbs that act on nouns or actions that act on ingredient objects. We also want to find meaningful segments in the recipe. So if you have, we don't want to just look at one big instruction, right? Because that has several different steps inside of it. Even if we cut it up into different sentences, we don't always have the meaningful segment, because here you have slice the apple and put into pan. But we want to find just the verb phrases. So we take the conjunction here and we split it whenever its parent is a verb phrase, so that each of the two children that we get are verb phrases too. This is the dependency parse, and we can use those to find specifically which actions correspond to which nouns. So if we have cut the apple into slices here, and we do a dependency parse, we find that apple is the direct object of cut. And here's some of the sample objects and actions that we extract for apple. We get nice things like apple, chopped apple, apple slice, but we also get some kind of weird things like apple cinnamon flavored low-fat yogurt, and place the apples in. So these sorts of differences can mostly be attributed to the Stanford NLP parser being trained on newswire text instead of cooking recipes. And ultimately, newswire text is very different from cooking recipes because in newswire text, you have like really formal English, like standard English, one might say. But in recipes, you have like paraphrases, like add the apples, bake for 50 minutes. Not really a complete sentence you might find in standard English. The actions are pretty okay, because we're just mostly looking at verbs instead of, just the verbs there. So let's say now that we have a decent knowledge graph of objects and their states and the actions that move them. We'd also like to add some visual information to this. So we have apple that goes to some whole apple here and apple slices that go there. This would be like the ideal thing, right? So for that, we collected some data from ImageNet. We took 180 different base ingredients, so like apple, tomato, not sliced tomato, and searched on ImageNet for those ingredients and took a couple hundred images from those, which gives us about 110,000 images for those. And for the in-between states, like sliced apple, sliced tomato, what we do is go to Google and search and query for those things. Like we query sliced apple and grab however many images from those. So now if we go back to the image classification problem, like I said before, we want to classify these in some way. And there are several different ways to do that. But one of the more recent and one of the more successful ways so far has been through deep learning. And Google just recently put out their new deep learning framework called TensorFlow. Basically, it's just training it on a bunch of images and learning some weights across here. And then you output labels at the end. So what we'd like to do is use one of these pre-trained models. So a model trained on the 1,000 categories and 1 million photos, like I said before. And just use all of their learned features, and then take our data, cut off this edge here, and learn our own labels. So for starters, we just did the 100 base categories. So just apple, tomato, not sliced apple, not sliced tomato. And we do okay. We do like 50% accuracy. So top one error just means that it's classifying what it thinks is most likely. And this is okay because the current state of the art is around 60, 70%, I'd say. But this is only on these sorts of images, these sorts of categories, just apple, pear, tomato. So from our knowledge graph, we now have to choose among a lot of different images that we've picked out. So for apple and sliced apple. But you can see that these images aren't really very descriptive of apple per se, because this is an apple and 2 bananas, right? This is sliced apple with some cinnamon. And when we put this image into the classifier, we want it to classify as apple, but it actually classifies as like celery or mint because it's green. So yeah, we actually went into this hoping there'd be some better data to collect. We were hoping that there'd be like images for step-by-step instructions. And with like really nice images like this would be perfect. But there just aren't that many blogs online that have this sort of data. So what would I like to do? Well, it'd be cool if we could incorporate some video into this, because video has a lot of cool information, like as information about in-between states, like all this ginger root that's being sauteed here. And it has information about mixtures of ingredients. So like if you were trying to classify something like this, it's not just carrots, and it's not just mushrooms, and it's not just bok choy, I think. And also like to expand upon the domain. So not just cooking, but also in other how-to domains, like instructables.com. Like these are basically recipes, but not for food. They're for things like building desks or building gadgets. And I think this would be really cool as an application for robotics. So this video is actually from a group at MIT, and this is their BakeBot. But all it really does is doing like stirring, mixing, and placing things, and it uses like an easy bake oven to make stuff. If we knew how to correctly identify states of objects, I think it'd be like really cool to have this working. And I think I'd like to take the time to thank both Tamara and Alex Berg for their help and guidance, and also Miko for his help. And that's all. Thanks.